Level 1, Gear Fundamentals. Lesson 3, What happens when gears are different sizes? In Lesson 2, we used two gears that were the same size. But what happens when one gear is smaller and the other is larger? Here we have a 8-tooth gear meshed with a 40-tooth gear. The smaller gear has 8 teeth, and the larger gear has 40 teeth. Because their teeth are meshed, turning one gear causes the other gear to turn. First, let's make the 8-tooth gear the driver. As I turn the small gear, watch the larger 40-tooth gear. The large gear turns in the opposite direction, just like we learned in Lesson 2. But notice something else. The larger gear turns more slowly than the smaller gear. Why? The small gear has to rotate several times to move all 40 teeth of the larger gear through one complete rotation. So when a small gear drives a large gear, the output becomes slower. But slowing the gear down also gives us another useful effect. The larger driven gear can produce more turning force, which is called torque. So a small gear driving a large gear gives us
less speed, but more torque.
Now let's reverse the roles. This time, the 40-tooth gear is the driver, and the 8-tooth gear is the driven gear. Watch what happens when I turn the large gear. The smaller gear spins much faster. So when a large gear drives a small gear, we get
more speed, but less torque.
And once again, because these two gears are directly meshed, they still rotate in opposite directions. So remember, when a smaller gear drives a larger gear, we trade speed for more torque. When a larger gear drives a smaller gear, we trade torque for more speed. This relationship between the driver and driven gears can be measured, and that measurement is called the gear ratio. You are now ready to progress to Level 2 of the series, where you will learn about gear ratios, speed and torque in more detail.